For tonight, why everybody is here and why I'm excited for this evening is we have Erica Fleishman here to talk to us a little bit about last year's wildfires and some of the issues that are related to that. But before we get started, I wanted to give a little bit of background. So Dr. Fleishman received her master's in biological sciences at Stanford University. She holds a PhD in ecology, evolution, and conservation biology from the University of Nevada, Reno. She is a professor now currently with the College of we've changed the name like a year and a half ago and I still can't get it right. The College of Earth, Ocean, and Atmospheric Sciences at Oregon State University, where her research is broadly centered on ecosystem, community, population responses to climate change. Erica is currently the director of the Oregon Climate Change Research Institute, which is a network of over 100 researchers at OSU, the University of Oregon, Portland State University, and Southern Oregon University, and affiliated federal and state labs. The Oregon Climate Change Research Institute also houses the Oregon Climate Service, which is recognized by the American Association of State Climatologists as Oregon's official state climate office. We are very honored to have her here today to share with us the things that she's going to talk to us about these wildfires, which has a lot of interest here on the coast. So Erica, the stage is yours. I'm going to have you take it away.
Great, thank you so much for the opportunity to talk with all of you and for that kind introduction. And as Cinnamon said, there we go. Hopefully that is working. As Cinnamon said, I am not going to be upset if I don't get through the slides that I have prepared. Hopefully, if I went through all of them, there still would be plenty of time to talk. But please, if you have comments or questions or anything like that, I wish we were all in the same place and having a regular conversation. But let's stop and talk throughout as things come to people's minds. All right, so Cinnamon, thank you for your terrific introduction to the Oregon Climate Change Research Institute, or OCRI. I wanted to let people know who we are. Thank you if you pay taxes in Oregon because you are contributing to OCRI. We were established by the state legislature in 2007, and as Cinnamon said, we are housed at Oregon State, but we are not a fully owned subsidiary of Oregon State. So we have a network of researchers throughout Oregon's public universities. We work with a lot of federal and state agencies and non-governmental organizations and with private partners, and we are the home of the Oregon Climate Service, the state climate office. Larry O'Neill is the state climatologist. In general, our remit is to be conducting research on climate change as it pertains to Oregon and the effects of climate change on Oregon's natural and human systems. And to the greatest extent possible, we work with the public for questions that they might have, information that they might need. We work with local governments or organizations working with local governments and with the state as well. One piece of our remit from the state is to conduct Oregon climate assessments every other year. These are generally analogous to the national climate assessments, which usually come out every 4 years. And in turn, those national climate assessments are roughly modeled on the Intergovernmental Panel on Climate Change assessments. So the Oregon climate assessments, you can either, if you're interested, either go to the website at the bottom of this slide, or just use your Google skills and type OCRI Oregon climate assessment or something like that, and you should be able to get there. These are peer-reviewed, and they address what we know now about climate science and its effects, relevant really to the Northwest, but of course with a focus on Oregon. And these assessments are requested by the legislature, and they're intended to inform actions and inform discussions among Oregon's residents. We're really pleased that the 5th Oregon Climate Assessment, which came out in January, that we were able to produce that in association with the state of Oregon's 2021 Climate Change Adaptation Framework. That adaptation framework was led by the Department of Land Conservation and Development, And it's not meant to be a list of actions that Oregon is supposed to take or anything like that, but it's more of a means for the several dozen Oregon programs and agencies to be able to work together more effectively to kind of share strength on addressing climate change issues. That state climate change adaptation framework is being incorporated into Oregon's natural hazard mitigation plan, which is part of what allows the state to access FEMA funds. And both the state climate change adaptation framework and the Oregon climate assessment that OCRI produced have a really strong emphasis on climate equity and social justice. So turning to wildfires, what I've been asked and what a lot of people have been asked and a lot of people have been wondering, what caused the wildfires that occurred across Oregon and really across the Western United States last year? So the theories have abounded. It's not terrorist organizations and it's not space lasers, but people have often asked, okay, is it climate change? And the consensus among scientists is, well, in part. So what does that mean in terms of in part? We have lots of observations on climate. We have lots of projections on climate. How does all of that relate to what's happening with wildfires across the Western United States? So how can we say, well, in part? How can we be sure that in part, or how can we have high confidence that in part the wildfires across Oregon last year and across the West are attributable to climate change? So there is an area of climate science that's called attribution. It's common to other fields as well. And what that does is look at the relative contributions of different potential causes to either an event or some class of events. So when that's used in the climate context, it can apply to changes in some type of annual variable, maybe annual temperature. It can apply to seasonal conditions. And again, it can also apply to individual events such as a hurricane, or better yet, to classes of events. So to hurricanes in general or to wildfires in general. And so in this case, some colleagues of ours have looked at attribution of wildfires in the Western United States over the past several decades to climate change. So they're saying, to what extent is the trend in wildfires across the Western United States attributable to climate change? And the reason that it's possible to do this is that it's well known that aridity is related to climate in various ways. And when it's dry, vegetation, which is also called fuels in the fire world, aridity makes vegetation drier. And most of us have had the experience with campfires or anything like that, you don't want to light a fire with green wood. It's just going to smolder. You want that nice dry vegetation, or, a newspaper or something like that. But dry vegetation is faster to ignite, and it burns and it spreads. So in some cases, that's what you want. In some cases, that's obviously not what you want. And a number of measures of vegetation dryness were correlated with the area that burned in Western forests. And I'm talking about, forests, not all ecosystems, over the past several decades. And so then what one can do is to look at climate variables that affect the dryness of vegetation with and without climate change. So for example, one could say if temperature is increasing by a certain amount and that's associated with aridity, how much of that temperature increase appears to be a result of climate change? So you're basically saying what would happen with and without the climate change. And what these scientists discovered is that the increase in aridity that was attributable to climate change, as opposed to natural variation in climate or anything like that, probably led to a doubling of the area that was burned in Western forests over that period of several decades, 1984 to 2014. Okay, so aridity is increasing and it's changing wildfire patterns. Why is aridity increasing? What we're seeing here is the most recent US drought monitor earlier this week. So, it's not going to be a surprise to anyone here. Much of the West is in pretty extreme drought, and that is definitely the case in southern and central Oregon right now. So what's happening? Why is aridity increasing? Lots of factors are contributing to aridity. One of them is temperature. So, and if you want more details on any of this, we have more details on these changes in the 5th Oregon Climate Assessment. So temperature has increased by several degrees Fahrenheit in Oregon over the past century plus. RCP 8.5. Okay, so there are these scenarios of emissions, of greenhouse gas emissions that are called representative concentration pathways. And they basically say what is going to happen with the global level of greenhouse gas emissions. RCP 8.5 is generally considered a higher emission scenario, and it assumes that the rate of increase in global greenhouse gas emissions is going to continue through the end of the century. It's possible that that is an overestimate, and that that the rate of increase may level off by mid-century, and that would mean that the increase in temperature would be less. But right now we're on track or exceeding RCP 8.5, so that's why I'm referring to it. And that's the most technical thing I'm going to say all night. So assuming that, we're looking at increases of 5 degrees in annual temperature by the 2050s, and more like 8 degrees by the end of the century. So temperature is increasing. It's increasing during all seasons of the year, but it's increasing the most in summer. And so as a result, in Oregon and across much of the Western United States, there are more days that are hot, and it's hotter on those days. And it doesn't matter what threshold you use for hot, whether it's 86 degrees or 90 degrees, or whatever threshold you want to say is hot, we're going to have more of those days, and they're going to be hotter. Something else that's going on is, in a relative sense, the nighttime temperatures are increasing more rapidly than the daytime temperatures. So we don't have that kind of passive cooling as much. I mean, it's still pretty cool at night, but we don't have as much passive cooling as we used to. And that has effects not only on fire dynamics, but it has effects on many aspects of public health, because it's more difficult to kind of get that respite from heat overnight, especially for areas that urban heat islands or places that don't have any type of passive or active cooling system. Okay, so it's getting hotter, and that is contributing to aridity. Precipitation, I think many of us kind of have the sense that if there's more precipitation, it's going to be less arid. And that's not necessarily the case. So precipitation in Oregon across the year is actually either stable or increasing slightly, and that's projected to continue, perhaps a slight increase in total precipitation over the year. But what we're seeing is more precipitation in winter, less in summer, again in summer when it's becoming disproportionately hotter. We're seeing heavier winter storms, so flashier precipitation, which is more difficult for soils to store, and more precipitation coming as rain and less as snow. So we're seeing smaller snowpacks, we're seeing snow melt coming earlier, we're seeing enough snowfall for recreational activities accruing later, things like that. So even though we're getting more total precipitation, in a sense, the water availability is decreasing, and that's contributing to aridity. So what this means here, basically look at the bars on the bottom, and that tells you when there's drought and how extreme the drought is. So drought across the Western United States is becoming more common, it's becoming more intense, and it's affecting larger areas, and that is likely to continue. So drought, more drought, and that's obviously aridity. Just as a side note, other things that contribute to aridity include humidity, wind speed, and solar radiation. And there's some evidence that humidity is decreasing, especially at night, which can make controlling fires somewhat more difficult. And that's in Oregon. Okay, so what else is going on? What else caused the wildfires last year, and what else is contributing to, what else contributes to wildfires in general? So a big one is wind. What part of the reason in this satellite image that we're seeing the kind of smoke plumes that we are is, I know everyone here is really aware of this, we had some really, really strong east winds last September. So we had really dry vegetation, and we had really high winds. And so that means that last September, the burning index is one of many measures associated with fire. It basically means if a fire starts, how difficult is it going to be to put out? And so when the fires in Western Oregon started last September, the burning index was extraordinarily high. So that meant, if a fire starts, it's going to be very, very difficult to control. I've been asked a number of times, and other people are being asked a lot, so what's happening with climate change and wind? There is right now pretty much no evidence in the observational record that winds are becoming more or less strong or more or less frequent. And wind is pretty difficult to project, but right now we don't have really any good evidence that wind patterns are likely to shift. So we have, or I guess I should say that those east winds are likely to become more frequent or less frequent. So, we're going to continue to have periodic strong easterly winds as we've had in Oregon for quite some time. Okay, so you have high winds and you have dry vegetation. What else is going on? Well, you need a spark to create a fire, right? So they're not, especially when we're not getting a lot of lightning in the state in summertime. It's going to be something that is often human ignited. And across much of the West and across much of the United States, in recent decades, the proportion of fires that have been ignited by human activity has increased substantially. And when I say human activity, I'm not talking about arson, although there are a small number of arson fires. But basically, humans, when we're humans just doing our thing, we create sparks. And we create sparks from lots and lots of different activities. In the Northwest, many of our sparks come from agriculture, and that could mean that people are burning debris, which is allowable under many conditions. It could mean that a hot tailpipe touches some dry vegetation. It could mean power line failures, anything associated with people doing their thing and with the infrastructure that's associated with human activity. So you have, the combination of aridity, dry vegetation, high winds, and then a spark. And that's what's causing fire. Okay, so what is happening in terms of fire patterns in Oregon? This graph is showing the area burned across all of Oregon. So last year, a lot of the extent of the fires was large, but it wasn't the largest on record. Western Oregon, different story. Recent research is indicating that the area burned just in Western Oregon last year was the greatest on record. But keep in mind, I think especially outside Oregon, when people are interested in the fire season in Oregon, they're not necessarily thinking about the fact that Oregon is not all temperate rainforest and old growth trees. So sometimes it's useful to remind people that we have all kinds of ecosystems in Oregon, and there are differences in the fire patterns across the state. Okay, so that's what we've observed. What are we projecting? The projections from many scientists are that the area burned and the frequency of fire is likely to increase over the next century. And the increase is going to be most noticeable first east of the Cascade Range, where fires, historically have been more frequent, generally less hot, different, more sparsely wooded ecosystems, and then west of the Cascade Range. And west of the Cascade Range, where you have the higher precipitation and you have the older trees that many times don't die in a large fire, it's like that green wood. You need really extreme conditions for fires in those wet ecosystems to really get going. So it's kind of circular. The fires that happen in Western Oregon are likely to be pretty intense because it takes those really extreme conditions to get a fire going in much of Western Oregon. What's not clear in these projections is whether fire severity is going to increase. And there are severity can mean a lot of different things. One way of thinking of it, one of the definitions is the extent to which vegetation is killed by the fire. So if you think about, many trees that can withstand fire and they're fire scarred, but they're not dead. It's not clear right now whether the proportion, say, of trees that are killed in these fires is likely to increase. Fire preparedness in Oregon, what can one do? Over the long term, obviously, since climate change is one of the factors that's contributing to changes in fire dynamics, reducing global emissions of greenhouse gases. That's a long-term activity. It's not a really sexy activity when people say, well, what can I do to reduce either the risk of fire or the risk of losing my home in a fire? But it certainly is a long-term factor to be thinking about. There are other things that people are thinking about in terms of preparedness. And these relate both to reducing the likelihood of a fire in the first place, and also to recognizing that fires are going to happen, but gosh, it would be great if there was less destruction of structures and less loss of life. So defensible space in Oregon is not yet policy. The number of people that are living in areas that are fire prone is increasing. Just the number of people is increasing. And again, keep in mind that, you know, when you have more people, you have more sparks. Although defensible space is not yet policy, there are a number of community-based organizations, fire district, extension programs that are all trying to work with landowners and communities in terms of what to plant, where to plant, how to clear vegetation around structures, things like that. Some work in California has suggested that in these fairly extreme wind-driven fires, a lot of structures ignite not from adjacent vegetation. So it's not that a tree next to your house catches on fire and the fire spreads to the house, but because there are embers that are blowing pretty far, up to a mile or more in front, ahead of the fire front. And so often those embers will get into a structure's ventilation system, and that's what lights the structure on fire. So there are a number of things that can be done with the way in which homes are ventilated, or the building materials that are used to make homes more resistant to fire. This is being recognized across the West. It's one of these trade-offs. The initial investment in terms of materials can be somewhat greater. So, you know, what's the trade-off? It's construction is more expensive, but hopefully you're not going to have a structure burn down and have to rebuild. So this is probably something where there's going to be, if this is going to happen in terms of changes in building codes or voluntary construction methods, where, you know, the insurance industry and the building industry and communities and lawmakers are all going to need to have the will to create these changes. So there's a lot that people can do if they have the will to do it.
So we have a question
yeah.
in chat. Asking if what is the increase been of people living in areas with high wildfire risk? And they give an example that 1.2 million in 2010, but do we have any comparative figures for now?
There may be, and I don't know that number. I would suggest that maybe a good estimate is, I don't know if the 2020 census data are freely available yet. They might be. I mean, so one could look at the zip codes that are in fairly fire-prone areas. The census, the U.S. Census makes their data publicly available. So one could look at the population increase in some of the parts of the state that have tended to be the most fire-prone in recent decades. I would say, you know, in the absence of me knowing those specifics, I'm not saying they don't exist, that if population increases right now in the West, almost inevitably there's going to be an increase of people living in areas that are fire prone. It's going to be really hard to not have that happen.
So not to let you off the hook, what the follow-up question is, how about earlier figures? Can we look at the trend?
Mm-hmm. Yeah. And I apologize. I don't know those figures off the top of my head, but it's not too difficult to overlay population density every 10 years or so, and to look at where fires have occurred, or to look at vegetation types with a little bit of knowledge about which vegetation types are more or less likely to carry fires. So yeah, absolutely, those trends can be examined over time. And in a general sense, the number of people living in fire-prone areas across the West has increased quite a bit. Both again, just because there are more people, period, because the population of the United States and of the West is growing. You have people moving from other parts of the country for amenity values, things like that. So it has increased substantially over time, and that often is referred to as the wildland-urban interface. So more and more people living in areas that are fire prone.
Thank you. And thank you for asking the questions. Keep them coming.
Yeah, for sure. Okay, so the other thing that I think is a contributor in terms of society is that in the United States anyway, there's kind of a history of looking at fire as as a bad thing, kind of in all cases. And there's a pretty long history here. So conspiracy theories have been going on for a long time. I mean, and not wholly conspiracy theories. World War II, you know, across the world, fire was a tool of war. And there was a lot of publicity within the United States that suggested, you know, preventing fires is one way to keep the homeland secure, and suggestions that that the enemy would ignite fires because, again, it was a tool of war. So there's been kind of over the decades sort of a social marketing basically to society to say fire bad. And then, you know, Smokey Bear. Smokey is great for encouraging people to put out campfires and put out cigarettes and things like that. But there's been kind of an attitude of, you know, fire is always a bad thing. And that's not necessarily helping in terms of reducing the likelihood of fires in some areas and reducing the likelihood of fire danger. Yeah.
We have a question that came in just about that as well. So U.S. officials said on Thursday they're going to try to stamp out wildfires as quickly as possible this year due to severe drought. Do you think that's a mistake?
I think it depends on the circumstances. So there's a lot of discussion about prescribed fire. And so the idea is that if fires are ignited intentionally when humidity is relatively high and winds are relatively low, that society has some, it basically says fire is inevitable, but society has some control over the conditions in which a fire occurs. And also recognizing that in some areas, fires haven't happened for a long time, either because they've been actively suppressed or because there have been changes in land use that have changed the fire dynamics. And so the thinking is, and there's pretty good science behind this, that if fires in some areas become more frequent and lower intensity, that's going to reduce the risk of extreme fires. So, you know, I understand the notion that it's dry and fires are more likely to escape containment lines in areas where, and this is my opinion. I'd like to think it's my informed opinion, but this is all, different people are going to tell you different things about this. In areas where there are a lot of people, yeah, it seems like a pretty good idea to get on those fires this year. In areas that are more sparsely, where residences are sparser and where fires are not going to heavily disrupt economic activity, I don't know, depends on the conditions. That's my opinion. I think other people could have differences of opinion that would be equally valid.
Thank you. That's the response to the question. Sorry, I'll be more clear. The person that asked the question said thank you.
Oh, you're welcome. Okay, so other things that are contributing to fires, especially in the east of the Cascades, fire dynamics are changing as a result of changes in vegetation. So some of you may have heard of cheatgrass, which is a non-native invasive grass. And regardless of people's politics and livelihoods, it is almost universally agreed that cheatgrass in the Western United States is a very, very bad plant. So cheatgrass ignites super easily. That's how it makes its living. It greens up earlier than native vegetation. It dries out earlier than native vegetation. It's highly flammable and it colonizes extraordinarily well after a fire or really after any type of ground disturbance, be it blading a road or livestock grazing or anything like that. So as cheatgrass has come in across the Intermountain West, and there are similar grasses in the Mojave and further north, the fire dynamics have changed. Fires have become more frequent and they've become larger as these grasses have come in. It's a really challenging situation. Cheatgrass covers very large areas across the Western United States, and it's really, really hard to get rid of it. So, you know, reseeding, trying to kill it, I mean, all kinds of things. It is quite a challenge, but it has changed fire dynamics. And so that is also something that, that we are living with. There has been a lot of discussion about vegetation removal, and I'm using the term vegetation removal rather than fuels management because I think it's important in discussing the trade-offs to think that, you know, fuels, it's also trees and shrubs and grasses, and there are consequences of that removal. They may be considered good, they may be considered bad, but this is how we're altering areas. So I often say that trees don't levitate. So, you know, one of the things that happens when areas are being managed to reduce the likelihood of fire, or hopefully to reduce the intensity of a fire, is that there's going to be ground disturbance. There's generally speaking no other way to manage large areas without having a lot of ground disturbance. So you have trade-offs potentially in terms of erosion. As I mentioned, there are these non-native grasses that do very well with ground disturbance. So, you know, it's kind of reducing one risk and in some cases increasing another risk. So there are those trade-offs. Also, that type of trying to manage plants to reduce fire likelihood or fire intensity, it can require a lot of maintenance in some ecosystems. So, you know, I've learned in Oregon, where it rains a lot over the past year, you know, it's not like you can weed once and then you're done. You have to do it again and again and again. It's continual maintenance, and that requires a lot of effort. And in the case of these areas that are being treated, it means, you know, going back, and that costs a lot of money, and that's not always the allocation of funds. So so it's tricky. And vegetation removal west of the Cascades is generally thought, again, there's going to be some debate about this. Most of the science that I've seen suggests that west of the Cascades, it's unlikely to be effective. And again, that's because to get a fire going in many wet areas west of the Cascades, you need really extreme conditions. And when you have a fire that is, you know, going in dry vegetation and high winds, those fires we saw last year, I mean, they're leaping rivers, they're leaping major highways, and simply thinning trees is not going to stop that type of fire. In other parts of the state where trees generally have been sparser and fires generally have been less intense, you know, maybe it changes fire dynamics in those areas. And then, you know, basically the questions that were brought up, prescribed fire has some promise, we think, but there are obstacles to that. So, you know, understandably, if you tell people in a fire-prone area that you are going to light a nearby area on fire, sometimes understandably people go, oh no, you're not going to do that. So that's kind of the trade-off, and prescribed fires do escape. But, you know, hopefully, even if it escapes, the conditions under which it escapes are less likely to lead to high damage than if there was no prescribed fire. There's also the obstacle that there are air quality codes, and so it can be difficult to get a prescribed fire going if it's likely to violate air quality codes. I mean, of course, one can then say, well, if we have an extensive wildfire, the air quality is going to be absolutely horrible, so what's the trade-off there? But these are the types of things that that come up as challenges to prescribed fire. And there's also kind of now I think, sort of considered a subset of prescribed fire, often called cultural fire or cultural burning, which recognizes that that indigenous peoples across the Western United States and across the world have a long history of using fire effectively to create the conditions that they want to see in their environment. And so there's been more and more interest in looking toward indigenous communities and saying, what have your practices been over time? And could some of those practices be applied now so that humans have more control over their environment? So the other thing I wanted to point out is just, you know, when homes are lost, when lives are lost, when economic opportunity is lost, it's heartbreaking and it is devastating. But fire is a part of every ecosystem. And in general, you know, places come back. And so there are many ecosystems that do just fine with fire. And it can be tricky to remember, you know, there are, I'm gonna put this in human terms, although I probably shouldn't do this. You know, there are plants and animals that basically are just waiting for a fire so that they have their time to thrive. If you think, for example, about butterflies, I've studied butterflies off and on over the years. They often do very, very well in the years following a fire, and then, naturally not as well in the years beyond that. So they can do great after a fire. And places come back pretty quickly, even when they've burned really hot. So this is a photograph from within the Rim Fire, which burned in and near Yosemite in, I believe it was 2013. So this is in an area that was classified as high severity. And this is the spring after the fire burned. So the fire burned August, September-ish. This is in April. And it was a dry winter. But, there are plants coming back very, very quickly. And especially when the dead wood is left there, a lot of animals, again, are making their living off that. So blackback woodpeckers, for example, do really, really well in areas after fires. So that's kind of their time to thrive. So, hearing things, homes lost, yes, it was devastated, but I'm going to encourage people to be a little bit skeptical when you hear in the news things like thousands of acres were consumed, or they were destroyed, or they were devastated. Yes, people's lives were affected, and it's a horrible thing. But many of these wildlands, they're not devastated; they are going to come back. So this is another example. This is an area in the Mojave that burned last fall, and this photograph is just from a couple weeks ago. So, native species coming back in the wake of a fire, again, even in a drought year in a super dry ecosystem. So I'm going to leave it there.
Okay,
yeah.
We have a question in the chat then, perfect. About what about reducing monocultural type forest as a way to reduce risk of fire?
Helpful. Monocultures in terms of trees often are planted, and there's a general ecological principle. General meaning it's often true, although not true in every instance, that where there's more diversity, there's more resilience. And so if there is a mix of age classes of plants and a mixture of tall trees and little trees and shrubs and grasses and things like that, generally the areas that have more diversity, a fire is likely to be patchier. So, even in the areas that burned in Western Oregon last year, you'll see areas that burned really hot, and right next to them, you'll see an area that didn't burn. And so when there's not a monoculture, it's likely to be patchier, and the recovery, that recovery cycle is likely to be greater. In a general sense, monocultures of trees are not the best thing ecologically. But people make the choices that they make, and there are reasons that there are monocultures. So I'm not trying to slam that, but yeah, not great ecologically.
So we'll let you, you were on your very last sentence before I cut you off with questions. So
no, that's it. That's all I got.
Great. So for folks online, keep these questions coming, and we'll work through them as they come in. Thank you so much for sharing with us. Whoops. So I'm going to see if I can go back to where the last question was. It says human population linked to increased fire. How does it compare to roads, even at lower population density?
How does human population compare to roads?
Yeah, so I'm having trouble with this question as well. So maybe the person who asked that question, could you expand for us? And maybe we can get a better answer for you. So I'm going to jump to another question. If 80% of fires are related to humans, is there an example? It's really hard when they all jump because all the questions are coming in at once and I can't keep track. Oh, okay. So the original question, are roads a higher risk than population density?
I would say no, although I can't, that is my best guess. There are fires that are ignited along roads. Well, I guess it would depend where the population density is. I would tend to say no. that, you know, when you have more people in general, you have more opportunities to create sparks in areas that are, I'm not talking about downtown Portland, but, you know, in areas that are more wildland urban interface. Some fires are sparked off roads, but I don't think that's one of the dominant causes of fires. I mean, roads create other kinds of problems, but I think for fire, I wouldn't say that roads are relatively speaking the greatest concern.
Okay, and Paul, can you expand on your question as well, so that I have a better way to ask that, and I will go back up to another question here. So the WUI is growing, and that might put a crimp in prescribed burning. And if wildfires can't be left to burn in the WUI because of this risk, so the forest can't return to a healthy status by fires, then what is the solution?
So my opinion is there can be, so the WUI is the wildland urban interface. So it's where people are living in areas that are relatively fire prone, more people moving into areas that are fire prone. Wildfires can, or prescribed fires can be implemented in the wildland urban interface. Society is risk averse. You know, it can be done relatively safely, in my opinion. Right now, in many cases, there's not a whole lot of will to do it, but I think that it could be done. And to me, obviously this is my opinion, but the trade-offs are still worth it. I mean, if you look at an area that is likely to burn in the next, 20, 30 years, do you want it to burn under conditions that you have more control over or conditions that you don't? So, I am hopeful that prescribed fire will be considered more in those areas. But I guess, another, I don't know if it's a solution, but it's the other piece of this is that, as we were talking about, there's kind of two things. There's the trying to reduce the risk of a fire, and then there's accepting that a fire is probably going to occur, and what can be done to reduce the risk of structures and lives and livelihoods being lost when a fire comes. So in my opinion, it's a bit of both.
And this is taking us a little bit aside, but has there been any results from the impact of the fires here on our rivers and streams from the sedimentation issues? Do you know?
I talked with a couple of people from Oregon Department of Fish and Wildlife not that long ago about this. My sense was that the effects have not been extraordinary. Yeah. And they were talking similarly about, in some cases, fire is a part of every ecosystem, and it, kind of depends on how often, how hot, all of that, but that there are some benefits in some cases to those systems as well from these periodic fires, that it's all part of a disturbance cycle with which these ecosystems evolve. So I don't know that much about it. There may have been some negatives, but to the best of my understanding, this was not a horribly negative thing in terms of the waterways. Now, I'm not talking necessarily about, I'm talking about sort of the waterways in more remote areas. I think that, and again, what I'm about to say, I don't know the data on, but there are increasing concerns about toxicity to groundwater and surface water from structures burning. So, our homes or buildings are filled with all kinds of stuff that we would not want to drink. And that goes into the water system when there's fire. So that's more, I think that's probably in some cases more of a concern than yeah.
The erosion risks.
Yeah.
Interesting.
Yeah, the erosion risks, that varies a lot.
So another question that's come in is, do you think enough has been done since the 2020 fire season to reduce the risk of catastrophic fires in the 2021 fire season?
It's hard to control that type of risk. So some work came out quite recently that was that looked at the conjunction of events last fall. And so it wasn't just the fact that it was super dry. It wasn't just the fact that we had really high winds. It was the fact that both of those kind of high end of the gradient occurred at the same time. And there is not a whole lot that humans can do to change the coincidence of those types of events. Mostly what people can do in those situations is what we hear from a lot of agencies, utilities, all of that. It's to not create a spark. Because if you need those three elements, you need dry vegetation, you need high wind, and you need sparks. Well, the only thing that humans can really control, the thing humans can control the most in those situations is the sparks. It's not entirely controllable. I mean, California now, it's pretty widespread, as I'm sure people have heard, to be doing grid shutdowns, to do electric grid shutdowns when there are really high winds in drought situations. And I don't know if that is being implemented yet in Oregon. I know it's being considered more and being considered more in other areas. Again, there are trade-offs. I mean, losing electricity for some people is a real health risk. But that is one thing that's being considered. My understanding also is that I am not a transmission line expert, but that there are ways to modify transmission lines so that basically they shut down on their own if there's certain types of damage to the lines. So I think more and more there's more consideration of how are fires starting, and it's not just the individual creating a spark, but our infrastructure creating a spark. So that's most of it in terms of what can be controlled with those situations.
So the question I was working on with Paul is about if 80% of fires are related to humans, and part of that percentage is agricultural fires. What programs are being developed to deal with that component of human-related causes of the fires?
To the best of my understanding, there are more considerations or restrictions being evaluated for debris burning or for burning fields. That's what I know about. I'm sure that there are things going on that I don't know all the details about. So, unfortunately, regulation, being careful, things like that. I apologize. I'm sure that there is more being done and more known, and I don't know the details.
Okay, so this question is, I've heard that ODOT is removing a lot of trees along the roadside that are considered a risk. Is that a fruitful approach at reducing fire spread?
Not in my opinion. Yeah. I don't really want to wade into that one. There's been a lot of debate about which trees are being removed and why they're being removed, and how much of it has to do with economics and perception and fire spread. And I don't envy people in ODOT that are dealing with making those decisions. That's my thinking on it.
So we have a question going a little further about the transmission lines, but thousands, and then you talked about it, so apparently you answered this question. So there's another question here. Thousands of bolts ignited hundreds of fires in California and at least one in Oregon, setting the stage for some of the most destructive fires in the West that we've seen in modern times. Andrew, do you want to finish your thought there for me? And while Andrew's typing, if there's any other questions, we have a few more minutes. So feel free to put them in. And while things are coming in, Eric, I just wanted to say thank you for sharing with us. I really appreciate you coming and being a part of this community. It's just nice to have you here to talk with us.
Yeah, thanks for the questions, because it points out to me things that would be good to look into more, and things that people want to know about. So I really appreciate it.
Great. So Andrew clarified for me. So if so many fires are caused by lightning, what are the ways that we can mitigate? Particular cause?
The ways that we can mitigate lightning?
Fires from lightning.
Fires from lightning. It's the same type of preparedness, knowing that, so I mean, for one thing, yeah, fires are going to happen in some places where there's lightning. And you know, I think in those cases, it's what can one do to reduce the likelihood that when a fire comes, it's going to cause a lot of harm to structures and to lives and things like that. There's been, I think, increasing discussion about ensuring that that alert systems are in good shape. So, I mean, there have been some horrible stories from last year about people who didn't know that a fire was burning, or people who didn't speak English that didn't get notifications. I mean, basically an infrastructure failure in terms of notifying people. So I think that's being considered more. Thinking about evacuation routes. I mean, in California in recent years, there have just been some heartbreaking stories about people that tried to get out and couldn't. So just like at the coast, we have, you know, tsunami escape routes and things like that. Okay, across the West, do we have fire escape routes? Do we have alternatives? Is there some kind of plan for control of traffic when there are fires in these areas? So there are, you know, a lot of things that can be done sort of at an individual level and a social infrastructure level to reduce some of the likely harm when a fire comes. You know, it's hard to do, but people talk about, you know, for example, know who the people in your community are that have limited mobility. And, you know, if you're going to be evacuating, go knock on that neighbor's door and make sure, you know, get them out if they can't get out on their own, things like that. So some of it is proactive and some of it is what do you do when the fire comes?
Yeah, many of us here on the coast dealt with both of those issues that you just talked about, the notification system and the evacuation procedures, and how to put those into place quickly and effectively, and making sure that everybody has that access. So a question just came in as well about how worried are you about this upcoming fire season?
I'm worried. I mean, you look at the trends in recent years and the trends have not been good. You know, paradoxically, I'm hopeful that the increase in awareness that resulted from last year, that will be a small silver lining in terms of the sparks and in terms of people being prepared to evacuate and having their go bags and having a plan. So I am hopeful that the human costs in various ways may be lower if we have those fires. It's just hard to say. You look at the overall trends and I mean, the not hopeful part of me goes, okay, this year might not be a bad year, but the trend is going in a particular direction. So, you know, I'm fairly worried, but I'm also worried about the Cascadia fault blowing. So I don't mean to make light of it. There are a lot of natural hazards that we can prepare for. I'm going to go off topic because I thought this was one of the best things that the CDC did. This was probably 10, 15 years ago. The CDC put together a website on how to prepare for the zombie apocalypse. And they went through all the ways in which you could prepare for this. And then they mentioned, but, you know, in preparing for the zombie apocalypse, you're also going to help your preparedness for floods and fires and, you know, other types of extremes. So we can all probably do more in terms of preparedness.
And so now you're talking where I kind of live. I work really hard with this community to make sure that we're ready for a Cascadia level event. So go bags, and just knowing where to go and who to talk to and knowing your neighbors and knowing where to go is a really big deal. So that kind of took my wrap up question for you. I was going to ask, like, what do you recommend for us as we are thinking about this season, and what do we need to do personally, and what can we do more societally to think about how to be more prepared?
Personally, we can be really careful with sparks. We can, just as you said, we can have our plan. You know, and a lot of emergency management agencies are encouraging that. What's your plan? Where are you going to go if you're not with your loved ones? How are you going to meet up? I mean, have a plan. Have things that don't require electricity. Have water. Have food. You know, have a plan. And then I think, you know, something that people can do at a larger level is, you know, if you have the right to vote, if you have people representing you, tell your elected officials what matters to you. I mean, consider that something when you talk to them, say, hey, you know, this is how I feel about these things. What are you doing about this? This is a factor in who I'm choosing to represent me. So we have, you know, as a society, we have the capacity to speak up the chain. And I think that's an important thing to do.
Perfect. And with that, I think it's a good little bow to put on the end of this talk tonight. So for everybody online, thank you so much for joining us. It was really nice to have everybody here. And again, to have a conversation and to ask the questions. I really appreciate everybody being so engaged. Hopefully we will see you next year in the fall, our academic year, for continuing science on taps. And again, if you're interested in other events at Hatfield, check out our homepage and scroll to the bottom for that calendar of events. Thank you, everybody. For Dr. Fleishman, thank you so much for being here.
Yeah, my pleasure. Thank you all. Look forward to seeing you for real soon.
We'll give you a tour of the building when you come out to the coast. So that'll be amazing. So, all right, everybody, thank you so much. Have a good night. I'm going to end the presentation. You are getting, you're getting lots of thanks in the chat, and you're also getting, let's get prepared for the zombie apocalypse. So that might be our takeaway for tonight. Be prepared for the zombie apocalypse, and we'll be prepared for everything we need to be prepared for. So thank you very much. There, all the applauses are coming in. So thank you again. All right, everybody, have a good evening. Thank you.